Nathan Cruz here again, Director of the Precision 3D Division at Carlson Software. Give you a brief overview of the cost estimation feature that we have built into the P3D Culverts application. And what we do keep track of is the cost estimation for the various pipes and head walls that you insert into your scene. And one of the first things that that needs to be done is to pull up the head wall gallery and make sure that there's actually a unit cost associated with each head wall, aside from the $1 default that we have. And you can easily change that by clicking on Edit Properties and then modifying this unit cost. And then the total cost is automatically calculated based on the type of object. So head walls are counted as individual objects, whereas pipes are treated as a cost per unit length. And I'll show you that here quickly in a minute. So what I've done is gone through each one of these head walls, and all you have to do is highlight the head wall. You'll notice the graphics preview updates for it. You hit Edit Properties and scroll down to the bottom of the screen and modify the unit cost. And you can go through and do that for all of the head walls that we have. So let's go ahead and just place a few pipes and head walls to give you an idea of how the cost estimation works. And we'll go ahead and drop in. Actually, what I'm going to do is use a smaller head wall from Oldcastle, and let me make sure that we've got a value associated with that. A better estimate here would be $1,200. And the thing about these models, you can actually contact your manufacturer to put in more accurate estimates of what these head walls actually cost, just to get a better cost estimate out of the program and the reports. So I'll go ahead and close that, and then we're going to draw. We'll just draw a quick pipe in here. Change that to outlet control so we get a little bit more reasonable pipe. And then what I'm going to do is insert some of these smaller head wall, Oldcastle head walls onto this. And you notice that, as usual, drag and drop the head walls onto the pipe, and we see that looks like they should go in pretty well. Now, one trick that I haven't shown before, and we'll do this, and I'll make the surface transparent here. So that the pipe is a little bit more visible. What I'm going to do is actually modify the inverts of the pipe slightly, just to lower that pipe down into the ground a little bit further, because I can see I've got enough clearance here to drop it down. And the way P3D works is we basically snap the endpoints of the pipe to the ground. But if you want to try to force that down a little bit, to force the pipe lower into the ground as it actually traverses across your berm or your road or embankment, you could modify these values and drop them down. So instead of 269, we're going to try for 267 on the invert. And you notice that we're getting a different pipe calculation. And again, that's because we're a dynamic, interactive environment. All the changes that you make are instantly visible, but we'll fix that up here pretty quick. we'll make sure that the thing's going to drain going down to a 266. We could even bump that up just a little bit to have the slightest of slopes. And you notice the pipe size is actually still calculated. You notice the head wall, or the headwater boundary that we're getting here is still in good shape. And I will bring the surface back, and you notice that now the pipe is too far under the surface. So what I'll do here is go back to this and try to raise up this end by another ½ foot. Yeah, maybe even more than that. Let's see, to 69.5. Let's bring that up even a little bit higher. Okay. Now, you can also modify the slope. So, and the way the slope calculation works is that we hold the invert in, and as you type this slope value, and it should be negative if you want the water to drain nicely, but we'll give it a nice 1% slope, and we'll have it automatically calculate that for us. And you notice that at this elevation, it's giving us a pipe that's a little bit too large and cutting across and cutting into our road. So what we can do is modify this slope, give it a little bit more of a slope. We can also reduce this velocity. So if you know that a 12 let's see if the head wall will actually grade into here. It looks like it still might be a little bit high. So I'm going to bring this back down. It's going to recompute the pipe and the slope, but we still want to maintain our minus 1%, so we'll recalculate that endpoint. Now I'm happy with the way that the pipe is going through the surface, and I can see there should be enough clearance here, because the rule for the head wall grading is 6 inches below the back of this, and we can also modify that. So we'll highlight this head wall, and instead of a freeboard of 6 inches, we'll give it a freeboard of 3 inches. And we could actually make it 0 as well, to make sure that sits in there. And then we'll go ahead and click on Auto Design, and we'll see what kind of solution that we get. Which is really not a great solution, so we'll just drag that back out and basically start over. So I'm going to drop this down and pull it out just a little bit, and then I'm going to redesign that head wall. And that's a little bit better. So if the pond is getting in the way, then what you can do is shut the pond off. And here we're just going for quick placement of these head walls, just so I can demonstrate the costing aspects of this. So I'm not going to spend as much time trying to get the grading just exactly perfect. We're going to drop those guys in there. And this culvert pipe, we're going to make that a corrugated metal pipe. So obviously it's going to change the Manning's value here, which will give us actually a slightly smaller pipe, which is just fine. Which is just fine in this case. So we put in the estimate. Notice that the culvert pipe. So now we know it's a CMP pipe, and it's 24-inch diameter. The default again for unit cost length is $2 a foot. But if you happen to know that it's going to cost you $4.50 for that particular pipe, and that's per unit length. In this case, it's measured in feet. then your total cost is going to come out to, again, we have our currency unit settings to US dollars to 182.61. And so what you can do is if we can track this scenario total cost, and that total cost estimation basically is going through all the pipes and head walls in the scene, and it's telling me that it's going to cost $2,500 for materials. That certainly doesn't include the installation costs. But what's kind of nifty is we can come back here and we can quickly put in. So we'll turn the ponds back on. So we highlight ponds, go to display, turn them back on. And what I'm going to do is just draw a few quick culvert pipes in here where I think we're going to need pipes. We're going to put one in there. We're going to put another one in from this low point into here. Switch that to outlet control, give us a little bit smaller pipe. And here what I'm doing is just putting in enough pipes just to get a quick idea of what that may cost to drop these pipes in. And so how did that change the scenario? So I just added these pipes in. And the one thing that we don't have is since we don't have a super extensive library for cost of materials, when you do change the materials on here, whether it's concrete or CMP, you still need to put in the unit cost for that particular pipe. So every diameter pipe of a different material is going to have a different unit cost. So for this one, I'm going to put $3. This guy's a little bit bigger pipe, so we'll increase its cost as well. And interestingly enough, you see the red pipe, and the red pipe is basically saying there's no water here. It's not really going to drain anything, but we're just doing this for cost estimation purposes. Again, corrugated metal, and we're going to modify this $3.50 per unit foot. So by doing that, we just quickly put in place a few pipes, and we can go to our scenario, and we can see that so far we're up to $3,100 just in materials cost. And so you can go through and essentially either do your formal design, and as you're doing your formal design, when you've locked in your pipe diameters and sizes, put in an accurate cost per unit length on your pipes, and then we'll automatically calculate this total scenario cost. And so since we support multiple scenarios, you can create another scenario in here with the same surface that has a different pipe layout. Maybe it uses a different style of head walls, and you can quickly toggle back and forth between the two scenarios, and you can see what the cost difference is, as well as what the engineering design results could be. And that's always useful information to give back to the customer. So that's a quick synopsis of how cost estimation works in Precision 3D Culverts 2015.